Hello everyone. Today we will cover two sections, 12.1 and 12.2. 12.1, the algebra of functions, composite functions. So first we have the algebra of functions. If f and g are any two functions, so the sum f plus g or f plus g of x equal f of x plus g of x. The difference of two functions f minus g or f minus g of x equal f of x minus g of x. The product f dot g or f dot g of x equal f of x times g of x. The quotient f divided by g or f divided by g of x equal f of x divided by g of x, provided that g of x not equal to 0. Composition of two functions. So f circle g of x, so that now this symbol is read as f circle g of x is different than this one, the product. So this one is the product f dot g of x, while this one is the composition f circle g of x equal to f of g of x. Similarly, g circle f of x equal g of f of x. For example, let f of x, this is a function, equal 2x plus 1, and g of x is another function equal x minus 3. Find each function and its domain. So now let us find the difference of two functions, f minus g of x. So this is equal to f of x minus g of x by this definition. Now substitute for each function. F of x equal what? F of x equal 2x plus 1 minus g of x equal x minus 3. Simplify, just remove the parentheses, so equal 2x plus 1. So this negative is multiplied by x minus 3, so this negative means negative 1. So use distributive property, so negative 1 times x is negative x, negative 1 times negative 3 is positive 3. Then combine like terms, so 2x minus 1x equal x, 1 plus 3 equal 4. So this is the difference of two functions. Now the domain for this function, so this function is a polynomial, so the domain here is minus infinity to infinity. So here x takes any value, negative, positive, 0. So the domain is all real numbers. Now find the quotient f over g or f over g of x. This is equal to f of x over g of x. F of x is what? This is f of x, 2x plus 1. And g of x equal x minus 3. Now, this function is a fraction. So we know that if the denominator equals 0, we cannot divide by 0. So the domain here is all real numbers, except that makes the denominator equal 0. So to find the domain, if the function is rational like this, so we set the denominator not equal to 0. So x minus 3 not equal to 0. So then solve this an inequality. So x equal or not equal to 3. So add 3 to each side. So we get x not equal to 3. So the domain is all real number except x equal to 3. Or the domain is x not equal to 3. We can rewrite the domain in this form, in the interval notation. So the domain is minus infinity to 3, parentheses. So here 3 does not belong to the domain. Union 3 to infinity. So if we have here the number line, so this is the number line, this is the number line. Suppose this point is the 3, so we graph open circle at the 3. So the domain is all real number, all these points except 3. So an interval notation is from minus infinity to 3, parentheses, union 3 to infinity. Another example. Now, let f of x equal to x plus 1. And g of x equal x squared minus 1. Find each value. Find f of 2. To find f of 2, just substitute 2 for each x. So f of 2 equal 2 times 2 plus 1. 2 times 2 is 4, plus 1 equal 5. Now, find g circle f of 2. G circle f of 2. So by this definition, g circle f of x equal what? Equal g of f of x. Similarly here, g circle f of 2 equal g of f of 2. Keep g. Now f of 2 equal what? Equal 5. Substitute 5 for f of 2. So now we have g of 5. To find g of 5, look at the function g. G of x equal x squared minus 1. So to find g of 5, so equal 5 squared minus 1. 5 squared is 25, minus 1 equal 24. So g circle f of 2 equal 24. Another example. Find g of negative 3. So to find g of negative 3, look at g of x. Just substitute negative 3 for each x. So negative 3 square minus 1. Negative 3 square is positive 9, minus 1 equal 8. Now find f circle g of negative 3. So f circle g of x equal f of g of x. So here if x equal any number, for example 3, we put a 3 here. If x equal 2, we put 2 here. So now I need to find f circle g of negative 3. So this is equal to f of g of negative 3. Now first let us find g of negative 3. G of negative 3 is given. G of negative 3 equal 8. Substitute 8 for g of negative 3. So now we need to find f of 8. To find f of 8, look at the function f of x. So if x equal 8, just substitute 8 for each x. So we get 2 times 8 plus 1. 2 times 8 is 16 plus 1 equals 70. Section 12.2 Inverse functions. Before we define the inverse function, we need the following definition: one-to-one function. A function is called one-to-one if different input values x in the domain determines different output values of y in the range. So for example, consider this function. This function is from a to b. If a is 0, 1, 2, and B 3, 4, 5. So the function f is defined as follows. So 0 is related with 4, 1 with 3, and 2 with 5. So now this is a function because the definition of function is what? Each element on the first set associate with one and only one element in the second set. So here 0 is associated with one element in B. 1 is associated with one element in B. And 2 associated with one and only one element in B. So this is a function. Now, is this function one-to-one? Let us use this definition. If different input values x in the domain, so take any two different values in the domain, like 0 and 1. So 0 not equal to 1. So different input values x in the domain. So now, determines different output values of y in the range? Yes. So now f of 0 equal what? The image of 0 is 4. And f of 1 equal what? F of 1 is 3. It is clear that 4 not equal to 3. So here the definition is satisfied. Different input values x in the domain, 0 not equal to 1, determines different output values of y in the range. We get 4 not equal to 3. So this is true for any two different input values x in the domain. You can choose, for example, 1 and 2. These two different input values. So 1 not equal to 2. F of 1 is a 3. F of 2 is 5. So it is clear that 3 not equal to 5. And similarly, if you take 0 and 2, 0 not equal to 2, so f of 0 is 4, f of 2 is 5, so 4 not equal to 5. So here the definition is satisfied. Any two different input values x in the domain determines different output values of y in the range. So we say that this function f is one-to-one. There is another method to test the function, is it one-to-one or not. So for example, if we have these three functions, the first one is this line, linear function. The second one is this function, which is perpendicular opens downward. And the third one is this. F of x equal square root of x. This is the graph for f of x equals square root of x. Now, let us check which of these three functions is one-to-one. So we will use horizontal line test. Horizontal line test. If every horizontal line intersects the graph of a function at most once, so one or no, then the function is one-to-one. So let us check here. Use horizontal line. So here, this is the horizontal line. Intersect the graph just once. So this is one-to-one function. While this function is not, because any horizontal line intersect the graph more than 1 point, in 2 points. So this is not one-to-one. This graph, or this function, is one-to-one because any horizontal line intersect the graph at once. So this function is one-to-one function. So you can use this definition or this one to test if the function is one-to-one or not. A graph, this is an example, graph y equal x squared. So this is the graph for perpendicular opens upward, this one. Is it a one-to-one function? Yes or no? So this function is not one-to-one because if we use the horizontal line test, any horizontal line intersect the graph at more than one point. So this function is not one-to-one. So here we circle the answer. The answer is no. Note, every one-to-one function has an inverse function. Every one-to-one function has an inverse function. So we use the function, or we use the notation f to the negative 1. So this is not a power, this is the symbol for the inverse function. So we use the notation f inverse to denote the inverse function. Now for each one-to-one function, we can find its inverse by switching the coordinates of the ordered pairs of the function. So for example, find the inverse of the one-to-one function. So here we have a function. This function is written as an ordered pair. The first one is 1, 0, 7, negative 2, negative 6, 3, 4, 4. So the first coordinate is the domain for the function. So this is function f. The domain here is the set of all first element of the ordered pairs, which is 1, 7, negative 6, 4. 1, 7, negative 6, 4. And the set of all second elements of the ordered pair is called the range. So here the range is 0, minus 2, 3, and 4. The second ordered pair. The second element of the ordered pairs, which is 0, negative 2, 3, and 4. So now, 1 is related with 0. So 1, the image of 1 is 0. The image of 7 is negative 2. Negative 6 is related with 3. 4 with 4. So now this is a function. Is this function one-to-one? So just switch this ordered pair. So here for each one-to-one function, we can find the inverse by switching the coordinate of the ordered pairs of the function. Just switch this ordered pairs. Now first, this function is one-to-one. Is one-to-one. So now if the function is one-to-one, we can find the inverse. Why it is one-to-one? Look here. Take any two different input values in the domain, like 1 not equal to 7. We see that 0 not equal to negative 2. Take for example 7 and negative 6. 7 not equal to negative 6. We get negative 2 not equal to 3. And so on. So this function is one-to-one. To find the inverse, just switch the ordered pair. So 1, 0 becomes 0, 1. 7, negative 2 becomes negative 2, 7. Negative 6, 3 becomes 3, negative 6. And 4, 4, the same. So this is the inverse of the function. So if you look at the inverse, the domain for the inverse function is the range for f. And the range, which is here 1, 7, negative 6, 4, the range for f inverse is the domain for f. So if we graph f inverse, the domain here is what? Is 0, minus 2, 3, and 4. 0, minus 2, 3, and 4. Then the range for f inverse, the range is the set of all second element of the ordered pair, which is 1, 7, negative 6, 4. Then 0 is related with 1, negative 2 with 7, 3 with negative 6, then 4 with 4. So this is the f inverse, this is the f. How about if the function is written like this? If the function is given like this, f of x equal 5x minus 1. How to find f inverse? So here use this procedure, finding the inverse function of a one-to-one function. First, replace f of x with y. Replace f of x with y. So here, f of x, replace f of x with y. So now we have y equal 5x minus 1. 2. Exchange the position of the x and y in the original equation. So here, y becomes x, x becomes y. So exchange the position of the x and y in the original equation. 3. Solve the resulting equation for y. So now solve this equation for y. So subtract 1, or first add 1 to each side. So we get x plus 1 equal 5y, negative 1 plus 1 is 0. Divide by 5. So 5y divided by 5 equal x plus 1 over 5. Or y equal x plus 1 over 5. Then the result is the inverse function. So the result here is the inverse function. Just replace y with f inverse of x. So now this y is f inverse of x. Then keep x plus 1 over 5. So this is the inverse function. So the inverse for this function, f of x equal 5x minus 1, is x plus 1 over 5. The graphs of a function and its inverse are symmetric about the line y equal x. I will give you an example. So we will graph the function f and the function f inverse. We will see that these two functions are symmetric about the line y equal x. So let us consider this example. Example, graph the function and its inverse function. So we have this function. So first, let us find the inverse, or first let us graph this function, y equal x plus 3 over 4. Y equal x plus 3 over 4. So this is linear function. To graph any linear function, we need 2 or 3 ordered pair. So let us take x negative 1, 0 and 1, then find y. So if x equal negative 1, so negative 1 plus 3 over 4 equal 2 over 4, which is equal to 1 half. If x equals 0, so 0 plus 3 over 4 equal 3 fourths. If x equal 1, so 1 plus 3 over 4 equal 1. So now, we have this ordered pair, negative 1, 1 half. So from the origin we move 1 unit to the left, then 1 half up, this point. 0, 3 over 4, this is the second one. Then 1, 1, this point. So now we have these 3 points, 1, 2, and 3. Graph a line passing through these 3 points. So this is the graph of the function y equal x plus 3 over 4. So now let us find f inverse, then also graph it. So to find the f inverse of this function, so first, so we have this function, okay. Now exchange the positions for x and y in the original equation. So y becomes x, x becomes y. Now solve this equation for y. So multiply by 4 to clear the fraction, multiply by 4 each term. So 4 times x equal 4 times y plus 3 over 4. So 4 is cancelled with 4. Divide out by 4, we get 1. So we get y plus 3 equal 4x. To solve this equation for y, subtract 3 from both sides. So we get 4x minus 3 equal y. Or y equal 4x minus 3. So now replace y with f inverse of x. Then keep 4x minus 3. So this is f inverse. So now the inverse for this function y equal x plus 3 over 4 is what? 4x minus 3. Let us graph this function 4x minus 3. So this function is 4x minus 3. So also this is linear function. Let us take also 3 points for x, negative 1, 0, and 1. Then find f inverse. So if x equal negative 1, so 4 times negative 1 minus 3. 4 times negative 1 is negative 4, minus 3 is negative 7. If x equals 0, so 4 times 0 minus 3. So 4 times 0 is 0, minus 3 is negative 3. If x equal 1, so 4 times 1 minus 3, or 4 minus 3 equal 1. Now graph this ordered pair in the plane. So the first one is negative 1, negative 7. So this is the origin. Move 1 unit to the left, then 7 units down. So 1, 2, 3, 4, 5, 6, 7. This is the first point. Then 0, negative 3. So 0 is the origin. Then negative 3, move down 3 units. This is the second point. Then 1, 1. So move to the right 1 unit, then up 1 unit. So this is the point. Now graph a line passing through these 3 points. 1, 2, 3. So we get this straight line. So this is the graph for f inverse. And this one, the red one, is the graph for f. If we graph y equal x, this is the graph for y equal x. So the dashed line is y equal x. So we see that the function f and f inverse are symmetric about the line y equal x. Are symmetric about the line y equal x. Another example. Find the inverse of this function. Find the inverse of f of x equal 3 over x cubed minus 1. First, replace f of x with y. So here f of x, we can rewrite it like y equal 3 over x cubed minus 1. 2. Exchange the positions of the x and y in the original equation. So y becomes x becomes y. So now we have this equation. Now solve this equation for y. So add 1. First, let us clear the fraction. So multiply by y cubed. Multiply each term by y cubed. So x times y cubed equal y cubed times 3 over y cubed minus 1 times y cubed. Or x times y cubed equals, so y cubed divided by y cubed is 1. So we get a 3 minus 1 times y cubed is y cubed. So now we have this equation. Solve this equation for y. So add y cubed to it. So these two terms contains y cubed. Let us move this term to the other side. Or no, we add this term to the other side. So add y cubed to both sides. So here negative y cubed plus y cubed is 0. So we get xy cubed plus y cubed equal 3. Then factor out y cubed. So we get xy cubed divided by y cubed is x plus y cubed divided by cube is 1 equal 3. To isolate y cubed, so divide by x plus 1. So now we have this equation. Divide by x plus 1. So y cubed equals 3 over x plus 1. Now, to solve this equation for y, take the cube root of both sides. So, the cube root of y cubed equal y, or divide the power by the index, so 3 divided by 3 is 1. So, y equal the cube root of 3 over x plus 1. Now, replace y with f inverse of x. So, this y is f inverse. Y here is f inverse of x. Then keep this radical, which is the cube root of 3 over x plus 1. So now this function is the inverse of this function. So the inverse of this function, f of x equal 3 over x cubed minus 1 equal what? Equal the cube root 3 over x plus 1. So try to solve some exercises from these two sections. And if you have any question, let me know. You can email me. Thank you.